All right, so welcome to lesson number 9. Today's lesson we're going to do kind of together here through this video. At the end of the video, I'll tell you to pause and try your homework, and then I'll also give you the answers through this video for the homework assignment as well. So one of the things that I want to make sure that you understand about this video is you can stop it and pause it at any time, all right, because remember you are trying to kind of learn from this. Luckily, lesson number 9 and lesson number 8 are very similar. There's really nothing new here. These are just kind of a bit more challenging examples of problems, only because they have more things to multiply out and things like that. With these equations, just make sure that you are not getting frustrated. I know sometimes you make a little mistake somewhere and then everything kind of blows up in your face. I'm hoping at this point as well, you've already watched the video on how to do these in the calculator, so you can kind of figure out what your answers are, so that when you are solving, it's kind of like a quick check to make sure that you have the right answer. So now that we know about the calculator piece here, I would actually plug it into the calculator first. So if I was plugging this into the calculator, I'm putting in a 3x3 matrix. So I'd plug in -6, -2, 4 is my first column. My second column would be 5, 1, -5. My third column would be 2, 4, 5. And my last column would be -11, -9, and -4. And remember, when you're plugging that into your calculator, you're using RREF. And you can kind of use all of the steps in that video to solve. So I'm just going to plug that in really quickly here. So you'll probably hear me hitting some buttons here. So while I'm doing that, you should be trying it. Make sure that you are getting the same answer I am. If you're still confused about how to do it, maybe rewatch that video. The video is pretty clear on how to plug it all in. And remember using RREF. It's towards the bottom. And you should get answers for this of x equals 4, y equals 3, and z equals -1. Now the nice thing about knowing these answers right away is now when we're going through and trying to solve, we can now make sure that we got the right answer before we move forward and try and find the other two variables. So on first inspection, I decide to multiply this second equation by 5. I want to do that so that all of the y's are going to be 5y or -5y. So that allows me to add the first equation to the last equation. So I have -6x plus 5y plus 2z equals -11. I'll add that to that last equation. The y's cancel. I'm left with -2x plus 7z equals -15. I then can choose the second equation because I've used the first and the last one. So if I take the second equation, which becomes -10x plus 5y plus 20z equals -45, that's I'm getting from multiplying by 5. I then can add that again to that third equation because that would allow the y's to eliminate. Y's eliminate. I'm left with the equation -6x plus 25z equals -49. Now I need to multiply something by one of those two equations so that I get it so that the x's or the z's cancel. I notice that if I make it so that if I multiply this by -3, the x's would be 6x and -6x, so that would cancel. So I'd get the two equations, 6x minus 21z, watch your signs, equals 45, and -6x plus 25z equals -49. The 6x's cancel. I'm left with 4z equals -4, or z equals -1, which is what I found on my calculator, so I'm on my way to the right solution. Now that I know z, I can plug z back in. So I have -6x plus 25 times -1 equals -49. The nice thing also about knowing the answers, I already know x should be 4. So if I don't get 4 here, I fudge something with one of the numbers or signs or something like that. So I get negative 6x equals negative 24, or x equals positive 4, which is good. So I'm on my way. Then I have to use one of these original equations, so I'll just use that first one. Negative 6 times 4 plus 5y, I still don't know why, plus 2 times negative 1 equals negative 11. That's going to give me 5y equals 15, or y equals 3. I know I'm skipping some of the steps of the algebra there, but I'm hoping at this point in this course you can solve an equation. All right, let's take a look at number 1. Number 1 says, do we always get a solution? And the answer to that is no, right? If you think about what we talked about in lesson 8, when we solved 2 by 2 equations, we know that that was the solution of 2 linear graphs that are intersecting or not intersecting. So we could essentially have lines that are parallel to each other here. The same thing happens with 3 variables. I can create 3 variables that just don't work for this. So when we're looking at that, there are really 2 things that we can see. We're either going to get it so that we eliminate more than one variable, and then all of a sudden we get a number is equal to a different number, which just doesn't make sense, so we know that that doesn't exist. Or we're going to get a variable like x is equal to a variable like x, which means there's an infinite number of solutions, which I probably actually won't see here. That's more of a pre-calc thing. So in the process of trying to solve this, I can kind of choose to eliminate one of the variables or multiple variables here. It really doesn't matter. I'm going to choose to get rid of x. So I would multiply this last equation by 2 and this first equation by 4. That would make it so that some of my x's are 8x and some of them are negative 8x. So I'll definitely be able to eliminate some stuff here. So only because I've already done this problem and I know what's going to happen here, I'm going to take a look at this second equation and the third equation. So if I add those together, which I'd eventually do anyway, even if I used the first one, I'm going to wind up getting a situation here where the x's, the y's, and the z's all cancel. Now, sometimes that's okay, but that gives me nothing is equal to negative 21. That doesn't make sense. So because this is not true, I know there is no solution here. Now, if you were to plug this in a calculator and make a matrix of this, you're going to wind up getting a row of all zeros, and that tells us that there's no variable that works there. Okay? So when we're talking about these systems in lesson 8, we notice that the systems are solving for the intersection of 2 lines. Well, if I have 3 lines, that means we're intersecting 3 lines intersecting in 3-dimensional space. That's what we're really solving for here. But again, I think we even talked about this in lesson 8. We're not really focused on the y in this particular example or these particular examples. We're just figuring out that we can. Okay? So let's look at 3. So for 3, we want to try and eliminate a variable here. Again, it doesn't matter really which one you pick. And the interesting thing is you can actually multiply the equations to get different y values or different x values in adding. I don't really want to do that too often because it gets confusing. So I see the y's. I have some positives, some negatives. I'm going to multiply this first one by 6, second one by 2, and the third one by 3. That's going to give me negative 12y's or positive 12y's. So if I choose to add the first equation to the last, the y's will cancel. So I'd have 6x minus 12y plus 6z equals 18. And I'd have negative 12x, just watch your signs, plus 12y, that's good, those will cancel, minus 12z is equal to negative 36. Now, if I was doing this without a calculator, I would actually probably divide through by something common. If you look at the second equation, I could divide everything by 3. the third equation, I could divide everything by 4. That would make things a lot easier here. But because of the calculator, we could always make numbers bigger, and that's a little bit easier to see, I think, than dividing. So if we keep going here, we have negative 6x minus 6z equals negative 18. So I've used the first equation and the last equation. I've yet to use the second equation. So that one was 6x minus 12y plus 6z equals 18. And I'll add that to the last equation, negative 12x plus 12y minus 12z equals negative 36. Y's cancel. I have negative 6x minus 6z equals negative 18. All right, so if I keep going here, I need to either eliminate the x's or the z's. So right now they're all the same term. So if I multiply one of these equations by a negative value, so like if I multiply this by negative 1, I'm going to get 6x plus 6z equals positive 18. Everything here cancels, and these cancel, so I have 0 equals 0. Well, that is a true statement, so that means there is an infinite amount of solutions. I don't even have to solve past there because there's literally nothing to solve for. Essentially what that's telling us is all three of those equations are actually the same line. All right, let's try one on our own. I will tell you that this next one comes out to actually have solutions, so don't expect something like infinite solutions or no solution here. Okay, so at this point of the video, I would pause it. This way you can attempt this on your own. All right, so I'm hoping that you've tried this on your own question, and now you're kind of just checking your work. If you were just unsure and you wanted to see if you started correctly, you could kind of play the first few steps here and then maybe pause it again and keep going. But really, trying this on your own is important. So let's take a look at what I want to eliminate. I see the y's are both positive and negative. I see the x's are close in number. So either one really works here. So if you chose to eliminate a different variable than me, it's okay. I'm more of a positive negative looker, so I'm looking for positives and negatives. So I'm going to multiply those first two equations by something. So if I take the first one, 2x plus 4y minus 4z is equal to negative 30. I could add that to the last one, so x minus 4y plus z is equal to 18. There was nothing to multiply there. The y's cancel, so I'm left with 3y minus 3z is equal to negative 12. So that was the first equation and the last equation. I now need to use the middle equation, so 8x plus 4y minus 20z equals negative 84. I'm going to add that to the last equation, and I can add it all up. So I have 9x minus 19z equals whatever that is, so negative 84 plus 18. So that's negative 66. That didn't look like a 9. I want to change that. Okay. So now I have to figure out something I can multiply by one equation to get to the other. All right, so I'm going to try and get rid of the x's. I'm going to do that by multiplying the first equation I came up with by negative 3. So I'm going to wind up having 9x minus 19z equals negative 66. Negative 9x plus 9z equals positive 36. The x's cancel. I'm left with negative 10z equals negative 30. Divide both sides by negative 10, and I get z equals positive 3. That's one of my three answers. Then I can plug back in, so I know 9x minus 19 times 3 equals negative 66. Well, if I solve that out, I get an x value of negative 1. Then I could plug x and z back in to find y, and I would get a y value of negative 4. Also, remember, you could check this right on your calculator to see that you got the right answer. So at this point, we're moving on to homework. So since we're moving on to homework, again, this would be a good opportunity for you to pause the video and be able to kind of go through and see if you're able to do these on your own. Also, remember, you could check these right in your calculators. All right, so I'm hoping that at this point you did pause the video, you tried the 2 questions that I'm asking you to do for homework. That's it, just 2. And you can kind of go through it now and see if you did them right. Okay? So for the first one, I would kind of get rid of the y's again. Again, you could get rid of other things here, but I like to kind of use the signs to my advantage here. So if I take the first equation, I'm going to get 2x plus 4y minus 4z equals negative 30. I could add that to the last equation, and the y's will cancel. So I'm left with 3x minus 3z equals negative 12. I then have used the first equation. I've used the last equation. I haven't used the middle one yet. So I'll give myself an 8x plus 4y minus 20z equals negative 84. Isn't this the same as that one? Actually, I don't have to redo this one because this is the same as the on your own one. Look at that. How many of you saw that? Because I didn't right away. But if you want to check your answer there, it's the same as the on your own question from the page before. So really the only question you had to do on your own is this last one. So looking at the numbers, I would get rid of the z's. So I'd multiply the first by 2 and the last equation by 6. That'll give me 6z's or negative 6z's. So I'm going to have 6x plus 3y plus 6z equals 16 for the first equation. If I add that to the last equation, I'm going to get 36x plus 24y minus 6z is equal to 120. And sometimes the numbers here will be a little bit large because you're multiplying by something, right? So sometimes that comes out to be a larger value, totally fine. If you're really good at seeing the different structures and stuff like that, you could even go through and divide through by common terms and such. It's not necessary though. So if you add it all up, you get that 42x plus 27y equals 136. So the only equation I haven't used yet is the middle one. Negative 5x plus 3y plus 6z equals negative 4. I have to add that to the last one again because that has the negative z in it. So the z's cancel. I'm left with 31x plus 27y. Hey, I like that because we have the same number already. Equals positive 116. So to get the y's to eliminate, we're just going to multiply the x, the one equation by negative 1. It's negative 31x minus 27y equals negative 116. The y's cancel. I'm left with 11x is equal to... All right, so let's pause for a second here because I did find a typo. I changed it here. It actually was supposed to be 2y there, right? So you wind up getting these two equations, which don't have this fun, fancy, common y value. So we actually have to multiply them by something. So when I stack them, so I have 42x plus 26y equals 136. And 31x plus 27y equals 116. Well, I'm just going to multiply the x values by each other. I'll just make one negative. So I'll multiply this by 31 and multiply this by negative 42. Well, that's going to give me is 1302x plus 806y equals 4216. That's going to give me negative 1302x minus 1134y equals negative 4872. If I eliminate all that, I get negative 328 y equals negative 656. Y value becomes 2. I can solve for the x value is also 2, and the z value, which actually becomes 0. So those are my 3 answers. Hopefully this video helped. All right, again, I know it's a longer video. Just make sure you pause and try some of the problems by yourself. Hopefully you're enjoying a couple days without me, and I'll see you all after the weekend.